Hey guys, welcome to my channel, the Tech Coders, and today we are going to solve question number 61 of LeetCode, that is rotate list. Okay, so question states that we are given with the head of a linked list and we are supposed to rotate the list to the right by k places. Okay, so let's understand with the help of an example what question is basically saying to us. So see guys, we are going to use this example where the value of k was 2. Okay, so let's see how exactly rotation works. So I'm saying that as we are supposed to rotate towards right, what we are going to do, we'll take each element, we'll shift it to the right, 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 and the last element will come at the front, and the last element will come at the front. Okay, as we're supposed to rotate it 2 times, let's do. I'm rotating it for the first time. So what will be my answer? I'll keep on shifting each element to the right. As 1 was over here, so 1 will come here, 2 will here, 3, 4, and 5 was my last element, so 5 will come at the front. Okay, now we'll do for the second time. Again, 5 was here, so 5 now will be here, like 1, like 2, likewise 3, and now 4 was at the end, so 4 will now come at the front. So this will be my answer. Now we have seen how rotation exactly works, how to move towards right and why to move towards right. Okay, so now see, this was a given linked list and we were supposed to rotate it by 2 times, and we have rotated it 2 times, and this is my answer. Okay, now see, this is my first element, that is the head, and this is my last element or node, that is 5. Okay, my head is 1, my last is 5. If I'll compare this with this, I can see that there is some link between the last node, that is the 5, and 1. Let's just forget about this one. Okay, just see this one and this one. What I can see is that my last node, which was here, it was the last node, and the head is having some connection, that is my 5's next is 1, that is my 5's next is 1. So let's do that. I'll make a connection with this node and this node. And how I can do it, let's see that. I'll take a temporary node which will initially hold this point, the head. Okay, and then I'll keep on jumping. I'll jump for the first time, then I'll jump for the second time, then I'll jump for the third time, and then I'll jump for the fourth time. Now my temp is over here. Okay, right now the temp next is pointing to null, but now I want to link temps next to the head. What I'll do a simple one thing. After reaching over here, I'll do temp dot next is equals to null. Temp dot next is equals to null. Okay, so now we have successfully created a link between my last element and the first element, like this. Okay, so now see, initially, as I said that initially my temp was over here, so how many jumps I made to reach my last node? That is the first jump, then second jump, then third jump, then fourth jump. So now the number of jump is 4 and the number of element is 1, 2, 3, 4, 5, that is n plus 1. Understood? The number of jumps I made to reach my last element is 4 and my elements are 1, 2, 3, 4, 5, 5. So my total number of elements in my linked list is n plus 1. Just have this in your mind. We are going to use this case. Okay, so now see, I'm saying that this is my last kth node. And as this was my last kth node, this is my last k plus 1 node. And now after seeing this, I can say that I'll take all the elements from my last kth node in the same order and I'll place them in front. And the remaining elements will be as it is. See, this was my last kth node, that is the last second node. Okay, I have taken 4 and 5, I place them in front, and all this 1, 2, 3 are as it is, as they were. Okay, the order has not been changed and nothing has happened with this. So how we can achieve it? So see, what we are supposed to change, we are going to make this as my last node and this as my new head. How is it possible? I'm saying that I'll reach at this node, and this node next is this one, okay, which we wanted to make as a head. So I'll do a simple one thing, that is head is equals to this node's next, and now I have changed my head successfully. Okay, now I have changed my head successfully, and now I'll do one thing, that is I'll place this node's next as null. I'll make this dot next as my null. So now see, when I made 3 is next as null, so this link is of no use, so I'll simply remove it. Now if I'll compare my given linked list, this was my given linked list, I've successfully modified it, and this is my answer linked list. So now I'll see that I'm having my answer with me. That is 4 is my new head, 3 is my last element, and rest the sequence is same. What I have done, initially I have reached to my last element, and what I did, I linked the last node with my first node, that is the head, the initial head. After that, what I did, I reached to my last k plus 1 node, and after reaching that node, I made a simple thing, that is I do head as this dot next, that is the new head as this dot next, and after changing the value of head, I'm doing that this node's next will point to null, that is this is gonna be my last node, nothing is after this node. Okay, yeah, this is what we have done over here. And now the question arises, how I can reach this node, how I can reach this place. Now this comes into action. What I said, that when we were doing this part, that is when I was linking the last node with the first node, at that time I made 4 jumps. Now imagine that initially I was standing at this position, that is my temp was over here, and I have to reach over here, so I have to make 2 jumps. To reach over here. Now my temp is here. So the value of k was 2. So how many jumps I should be making to reach last k plus 1 node? In this case, last third node, that is my n minus k. My n was 4, my k is 2, so I should be making 2 jumps. Let's see whether we are reaching in 2 jumps or not. Initially I was over here, I made 1 jump and I reached here. After that I made second jump and I reached here, and this was my intended node. Okay, so now I can say that I should jump n minus k times to perform this action, that is head will be equal to this dot next or the temp dot next, and my temp dot next should be equal to null. We are done with this. Now let's move to the case when the value of k is greater than the length of the linked list. So see, I have taken a small example to understand very well. So I have to rotate it for the 5 times. When I rotated it for the first time, for the case 1, what will be my value? It should be 3 1 2. For 2, it should be 2 3 1. For 3, it should be as it is, that is 1 2 3. For 4, it should be 3 1 2, and for 5, it should be 2 3 1. So now see, if you will compare this and if you will compare this, you can see that you are getting the exact answer. When you rotated it for the 1 time, you are getting the same value as when you are rotating it for the 4 times. When you have rotated it for this 2 times, you were getting the same answer as you rotated it for the 5 times. So can I say that I will rotate it how many times? K mod the number of elements in linked list. K mod number of elements in linked list. See how I'm saying this. The size of linked list was 3 over here. Now see this. 3 mod 1 is 1. 3 mod 2 is 2. 3 mod 3 is 0. That's why I got the same answer over here. See, 1 2 3 1 2 3, because I was not supposed to rotate it for any time, for 0 times. Now see, 3 mod 4, my answer is 1 1 1. That's why I got the same answer. Now see, 3 mod 5, which is equals to 2, So you can see that I got the same exact answer over here. So rather than rotating it again and again, before doing this procedure, what I'll do, I'll simply do one thing. I'll replace k as k mod n plus 1. As I said that, see, n is the number of jumps which we are jumping to reach the last node, but the number of elements in a linked list, the number of nodes in a linked list is n plus 1. Check again. We jump for the first time, we jump for the second time, third time, fourth time to reach the last node initially. Okay, so the value of n was 4. What's the number of element? 1 2 3 4 5. That is 4 plus 1, that is n plus 1. Okay, so I'll replace k with k mod n plus 1, and after that I'll jump for n minus k times. n minus k times. So yeah, we are done with all the cases, and now comes the edge case. There will be a situation when our linked list is empty. So it's of no use to perform all these operations, okay, because they are not going to add any value to us. This is my first test case, edge case, and second edge case is that when the value of k is equals to 2, which means that I'm not supposed to perform any rotation. I'm supposed to perform 0 times rotation, which means that we are not supposed to rotate our linked list any times. So this is my edge case. When I'll have either of this condition, I'll simply return my head. So now I think that I have considered all the logics and concept over here. Okay, so now let's move to the coding part. At first we'll check for our base condition, that is if my head is null, that is I'm not having any value in my linked list, or if k is equals to 0, that is I have to rotate my linked list for 0 times. I was doing one thing, that is I'm simply returning my head. I have returned my head. Now so as to connect my last node with my first node, I was taking a pointer as temp. Okay, so let's create that. So now we were iterating while my temp.next is not as equals to null. Okay, and I was doing simple one thing, temp is equals to temp.next. That's it. Okay, and over here I was also counting the number of jumps which I am making over here. Okay, so initially I declared a variable n as 0, and I'll keep on incrementing for every jump. Now I have successfully reached to the last element. What I was doing a very simple step, that is temp next is equals to head. That is my last node has been connected to the first node. Now we were doing what? We were going to the last k plus 1 element, we were changing the value of head, and we were making last k plus 1 element as the last node. So let's do that. Okay, so before that, what I said, that there may be situations when the value of k will be greater than the size of the linked list. So what we were doing at that time, we were doing simple one thing, that is k mod n plus 1. As the n was number of jump over here, so n plus 1 is the number of nodes in my linked list, that is the size of the linked list. So I have done this. So see, as I was supposed to reach over here now, okay, so how many jumps we are making to reach here? That is n minus k. So I'll store this value in a variable, that is jump. Again I'll make my temp as head. It was initially at over here. After that we were making 2 jumps. Okay, so that's why I made my temp as head, and while jump is greater than 0, that means I have to perform my operations for the jump times. Okay, temp is equals to temp dot next. Simple. When I'll come out of this loop, I'll be standing at this position. That is my last k plus 1 node. Okay, just in every step do this also, that is decrement jump by 1. What I said, as soon as I will come out of this loop, we were doing one thing, that is we are changing the head. What was our new head? That is temp dot next. Okay, and now as you were intended to make last k plus 1 node as last node, what you were doing, temp dot next is equals to null. That's it. Okay, now we have done everything. I'll simply do one thing, I'll return this head. So yes, now we are done with this code. Let's try to run it. I hope it will run successfully. Yes, it is running, and let's submit it. So yeah, it is submitted successfully. Okay, so this was our code, guys. I hope you understood all the concepts and the logic over here. So like this video, subscribe our channel, and share this with your friends who are participating in all this lead courses and code forces rounds. Okay, so thank you for watching and have a good day.